Right, so taking a look at differentiation, right? Before we go into first principles and like, one thing I want to remind you is that differentiation, most of it, 90% of it is complex, right? There aren't many new things in it, right? But of course, questions will be a little bit longer and to be a little bit more challenging. Not much more challenging, right? So let's take a look at the things that we need to remember from Form 5 first, and then we will move on to the new things like first principles and things, right? All right. So before we move on to write the first principles, this first principles thing is basically where differentiation came from. All right. So I'll do that after. Let's just run through some of the things that we need to know, because when you do first principles, you want to know the answer. All right. You want to know the answer. Okay. So let's see. To differentiate, what you do again? Bring down the power, multiply and minus 1 on the power, right? Bring down the power, multiply it, and then minus 1 on the power. Quick example, 3x squared is what? What's the differential of 3x squared? 6x, right? Bring down the power, write back the 3 and minus 1 to the power. Okay, so you end up with 6x. What's the differential of 4x? 4. What's the differential of 4? 0. Nice. What does this statement mean again? It means the differential of 2x with respect to x. Okay? And the answer is what? 2. All right? How do we differentiate things like this? There are two methods. One is the shortcut, and the next one is chain rule. So the shortcut is what? Bring down the power, multiply by the differential of the bracket, write back the bracket and minus 1 from the power. Okay, quick example, 3x plus 2 to the power of 4, bring down the 4, differentiate inside the bracket, write back the bracket and minus 1 from the power. That's okay? Right? And you could have also used chain rule, right? Right, chain rule could be written like this, or chain rule could be written like dy dx is equal to dy dx is equal to dy dt divided by dx dt. It could also be written like that, right? Same thing here. Okay, it can be written with the division sign or with the multiplication sign. Right? What's the differential of cos? Minus. What's the differential of sine? Cos. What's the differential of tan? So that's one of the new things in Unit 1. Right? In C-set, we didn't do that. Okay? So the differential of tan is sec squared. Okay, so make a note of that. Differential of tan is sec squared. Then you have your what? Product rule. So if you have a product, you use this. If you have a quotient, you use the rule underneath. Right? How do we differentiate things like this? How do we differentiate sine 3x? What will that be? Minus 3. Differential of sine and cos. So you differentiate 3x, put it in front. The differential of sine is, and then you write back 3x. Okay? Right? Since you're doing tan, Let's see if we do tan for the first time. What's the differential of tan 2x? Nice. The differential of tan 2x will be 2 x squared. Right? Just in case you forgot, 1 on sine x is cosec, 1 on cos x is sec, and 1 on tan. 1 on tan x is cos x, right? Just in case you forgot those rules. Right? 1 on just wait till you remember those small rules, right? All right, so that's the differential of sine and cos and tan and so on, right? All right. We're not going to any applications as yet, right? So let's see if we can practice a pure differentiation and do some first principles, right? So what is this first principles? Like kind of first principles. Kind of differentiation by first principles. Right, so we're going to take a look at differentiation of first principles, right? What this says is basically where differentiation came from. You sure pay attention? Oh, I see your notes tomorrow, huh? Come with me. Why not see the messages? Anybody can message, yeah? Anybody can message? It's not a random message. All right, got it. I'll see that now. Thanks. Right. So, what is this first principle? So, our first principle is basically where this differential came from, right? What does dy dx mean? Dy dx basically means the change in y with respect to the change in x, right? And this is technically what? Gradient, right? Technically the gradient. So this is technically the gradient. How do we find gradient? Y2 minus y1 over, right? That's technically gradient, right? So here's what they did, right? What they did is that they said that, so I can give you a little graph to see what's going on, right? Let's say we have this. This point here is x, so this will be your f of x, right? Let's go a little way down the road. Let's say somewhere here. Let's say the distance from here to here is h. So this is x plus h. Correct? Yeah. So if this is x plus h, what is this here? F of x plus h. Correct? So what is gradient? Gradient is y2 minus y1 over x2 minus x1. And this will cancel. Yeah. And if we watch how h behaves as it tends to 0, we have the differential. So dy dx is really the limit as h approaches 0 of f of x plus h minus f of x all over h. So you want to see how this function behave as h approaches 0. Right? That is the differential. Right? So this is the formula for first principles. All okay with that? So what you see before you write, some time to write what you see. Make sure you understand what's going on, right? So let's try an example. Let's see if we can differentiate y is, sorry, number is f of x, right? Let's see if we can differentiate f of x is equal to x squared. Sorry, yeah, you can come into that. Let me start here first. X squared. That's okay? What's the answer? What's the differential of x squared? So the differential of x squared is 2x. So we're supposed to get x squared, right? Before I do anything, what is f of x plus h? Right, x plus h all squared. Suppose I had a 2 here. It would have been 2 by only the x being squared, right? So we're trying to get this answer here. Let's see. So we're gonna apply it now, right? So the differential f prime x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. That's okay? F of x plus h minus f of x all over h. I'm going to expand on the top, and I will get x squared plus 2xh minus, yeah, I will write it at the end, but change my mind. Plus h squared minus x squared over h. X squared minus x squared is 0. So you end up with 2xh plus h squared all over h. Then you divide everything by h. This will cancel, and you will end up with the limit as h approaches 0 of 2x plus h. Remember, you're dividing h here and here, and you get this. What's the last step? When h is 0, what you'll get? You'll get 2x. Yeah? Because it's 2xh over h squared over h. This is the same as this. Right? When you find the LCM with 1h. So this means this. All right? So when you plug in h is equal to 0, you'll get 2x plus 0, which is 2x. Okay? So this is the answer. All right? Regional tools. Other tools. Copy it up. Let's go again. Right? So there's nothing really to remember. Just remember y2 minus y1 over x over h. That's it. Let's look at a few examples. This just fits me to take up. That is, you know, that last shot. How we do it now? Add a sphere or something. I see it, but how the fit? Huh? Right, some of them can remove the logos, they can find it for whatever they can use logo. What? So what's fitting it or what? Add the sphere. Right, it's like, let's say, finish? Let's take a look at a few examples, right? And then we'll do some. Yeah, this your downstairs, right? Huh? Yeah, I want to check that read. Let me show you and see. Huh? Yeah, they're coming to fix this stuff. Huh? I remind you, but that's the read pass it everything. I will check. All right, let's go. So let's take a look at a few examples that I have in the little handout before we attempt it. All right. So I have the same x squared example, right? We're looking up here. I have the same x squared example. Find the gradient. Did I show you where the formula came from? And we did the x squared example. All right. Let's check out this next example here. So of course, oh wait, I gave you this already. All right. Before I give you those two, what's this one here? Suppose I ask to differentiate. Suppose I ask it to differentiate the square root of 2x plus 1. Right? You'll see how I got f of x plus h? Yes, sir. I take off this and I put x plus h. And I left with the plus 1. 2 shots. Anyway, I think I fixed it underneath. Right? The plus 1 missing here, right? And then I put the minus sign. So I multiply it out and I got this. Right? But here's the problem. What are we going to do there? How are we going to simplify that? For those who did it already, what you do? What you do whenever square roots? Something else to simplify it. Both sides. I know both sides, only on one side. Kind of something like rationalize. Oh yeah. Right? It's the same. So it's rationalization. You should say something like this. Right? So here's what you're going to do. What you're going to do, right? You're going to look at the numerator and you're going to multiply by the conjugate of the numerator on top. With plus, right? And underneath. What will that do? What will happen now is that you're going to multiply this by this, and then this by this, and you will get difference of 2 squares. You'll see that? So therefore on top the root part will cancel off. Okay? the root part will cancel off and to look like this. Right? These squares will cancel off. Difference of two squares. And it will stay as it is. With the H sign, right? And then you work it out, simplify the H, you drop in that, you flip it over, and you end up with that as the answer. I'm going to show you on the board. And I don't like how it looks. Alright, so I'll give you a hard one time, right? How it is handle that square root. Let's do my favor, differentiate from now. What's the differential of this? So you know what to get. Differentiate that, please. So you know what the answer is. Right, what you all came up with? What's the differential of that? Huh? It'll be x plus 1. So we know this is 2x plus 1 to the half, right? So therefore, dy dx is you bring down the half, you differentiate inside the bracket, you put back the bracket, and you minus 1 from the power. A half of 2 is 1, so you'll get 1 over the square root of. That's the answer. Or you pull out the 2, differentiate the bracket, bring down the power, and differentiate inside the bracket, write back the bracket, and minus 1 from the half. Yeah, it's a shortcut rule, right? So this is what our answer is supposed to look like. Okay? Right, say our answer is supposed to look like that. So we're going to get the limit. So we're going to get the limit at h approaches 0 of the square root of 2x plus 2h plus 1. I'm multiplying this out. Minus the square root of 2x plus 1 all over h. Problem is we can't really simplify, we can't divide out h or anything. So once you see this, you're going to multiply by the conjugate of a numerator, which is the square root of 2x plus 2h plus 1. Instead of a minus, you put conjugate means that you're changing the sign here, right? The square root of 2x plus 1 all over 2x plus 2h plus 1 plus, remember this over itself is 1, right? If you multiply anything by 1, right, it will change its factor. Now, what will the numerator be? Difference of two squares, right? It will be this by this, which is 2x plus 2h plus 1 minus this by this, which is 2x plus 1. Please don't forget the bracket, otherwise you'll get this sign here wrong, right? Go right, just watch it. And I'm not taking it off. Right, Adrian? I'm not taking it off. All over h multiplied by this whole thing here. That's okay? Yeah. H by this. H by the square root of 2x plus 2h plus 1 plus the square root of 2x plus 1. You okay with that? Where do I go next? What's the next thing to do? Target here? Yeah. Simplify here, so I'll get 2x minus 2x plus 1 minus 1. And what will happen? So you'll end up with the limit as h approaches 0 of 2x will cancel, plus 1 will cancel, so I'll get 2h over h by open brackets, this whole thing here. 2x plus 2h plus 1 plus the square root of 2x plus 1. Are you okay there? Are you okay there? Online? Are you with myself? When you reach here now, what if you cancel? You cancel the h, so the h will cancel. What are we going to do after that? Can we do any addition here? Again? So when you reach here, you're not going to go around. Right. When you reach here, all we can do is substitute h is 0. Right? So we're going to substitute h is 0. All right? So let's put in h is 0 here. So we'll be left with 2 over the square root of 2x plus 0. That's an h there, right? So it will be 2x plus 0 plus 1. Nice? Plus root 2x plus 1. Do you recognize these two are the same? This is root 2x plus 1. So 1 root 2x plus 1 plus our next root 2x plus 1 is 2 root 2x plus 1. 2 will cancel and you'll get. All right? So the principle behind it is not QED. We just know what the answer is supposed to be. Right? So the main thing is this line here. When you multiply by this, leave your answer just like do not watch. Do not multiply it all by each other. Leave it just as it is. Leave it in numbers like this all the time. All right? And then things will cancel and then you can reach here. Any questions online? Samira? You okay with us? All right, copy it down. Wait, we missed a class in February, Carnival Monday. So this was early, so we could finish up before I went down. I was supposed to finish on the 17th of March. I just finished my one. But I did. Olha, vou ler os videos now. That's what we want to edit. And it's one thing I take a lot of talking and all the should be pay attention. I'll take out all that thing. Because give you on it to pay attention. It wasn't it?
Yeah. I see it was
Too many take too long.
What happened to
I decided I'm run the video. I would like drain me out. Yeah, a whole set I will release someone up for that. I'll do all that and I'll leave it at this.
Because that to be one man in Jamaica, do everything the opposite to real.
I'm trying this here. This is 2016. Try this please. Y is equal to the square root of x. Right? You do first principles. First principles of f of x is equal to the square root of x. And what? That's number 2016, number 6. Last part. Follow the same procedure, please. No, 2016, number 6, paper 2.
Last question.
Just this. First principles. Right? He just doing this alone for me. First principles differentiate the square root of x. Yeah, work it out. So we have tried that.
X plus H. X plus H.
Right, make sure you know what your answer supposed to look like, right? What's the answer for this square root of x? One and two. Nice. Right, so you multiply by the conjugate. Right, when you multiply by the conjugate, you'll get x plus h minus x. Right, most of the time, all the x terms supposed to cancel off in the numerator, right? Yeah. All how many h's? Cancel. What's the next step? Put h is 0, right? Yeah. So substitute h is 0. So that's 1 over the square root of x, because the point h is 0, right? Plus the square root of x. So you put h is 0. So you'll get square root of x plus the square root of x is 2. Square root of x. Root x plus root x is 2 root x, right? And that's the answer there. Okay. I know I didn't show you what, but I'm just going to come up with. Try that tomorrow. Right? I didn't show you, but you'll have to use some trig rules. Try that. What's the answer? Go ahead. Have fun. Answer process. Try this here. Let's see what the differential using first principles of sin x. Yeah, any questions online? Any questions online there? Oh, you already answered. Okay. Nice. Same tree. Right? You have to go back to the identity, right? Right? You have to go back to the identities to be able to expand it. All right, so let's see what you came up with. Let's see when you met the identities, what you did. So f prime x is equal to the limit as h approaches 0 of sine x plus h minus sine x all over h. So you have two options here. You can expand this out, or you could use the rule sine a minus sine b. Anyone could do it. I will expand this one out, right? I will use the expansion version. I'll show you, you'll get the same thing, right? So you'll end up with the limit as h approaches 0 of sine x cos h sine h cos x minus sine x all over h. All right? That's okay? So now let's break this up slightly. This is the limit as h approaches 0 of this plus this minus this. That's okay? So I'm bringing this here. So I'm going to get sine x cos h all over h. That's okay? Plus the limit as h approaches 0 of sine h cos x all over h. Actually, I should have factorized. And I gave you all the root cos h minus 1 on h. I gave you all that rule right here. So that would have been nicer if I do that, because I end up with a sine x on h. You'll get the same thing, you know. Yeah, I give you in the 4 rules. I'm bringing the sine x here together first all. I'm bringing the sine x cos h minus sine x on h. I'm bringing this together. Plus the limit as h approaches 0 of sine h cos x all over h. Right? So if you look here, remember the limit is with respect to h, right? So would the limit affect sine x? No. There's like a constant. So I could take the constant and pull it outside. So I'll end up with the limit as h approaches 0 of cos h minus 1 over h, and I'm pulling the sine x outside. Sine x by this is this, sine x by 1 is this. Okay? And I have a rule for this. I give it this, right? This is 0. Plus, I'm going to do the same thing here. Pull the cos x outside. The only reason I could pull the cos x outside is because this limit is dependent on how h behaves. H doesn't affect this. So this will always be constant, so I'll pull it outside here. So I'll get the limit as h approaches 0 of sine h on h. This value here is 1. This value here is 0. So I'll end up with cos x plus cos x by 1 cos x plus 0. Everybody okay with that? That's one option. The next option is to use sine A minus sine B. I'm going to factor formula, and then it will be and do the same thing. Yeah, product and factor. Me? Oh, didn't tell her that. So what do you do when you reach here? But you still rationalize? So why multiply by? All right, so whenever it's trigs, you do an identity. Square root, you're rational, right? Now look at this, right? So you have to remember this identity and break it down, right? But what you would recognize here that I did, you could have also done it what I was doing before, right? But you'll recognize here, I had to use the limit rules that they gave us, right? So I gave you 4 of them. I use one here and the one after. Oh, how that will help you?
Sine squared plus 1 is equal to plus 2.
You wouldn't get rid of this. So your every whole denominator still being 0. Right? Very rational, I do remember that. When I say I had to use identities, I remember saying that to them.
No,
Yeah?
We check back in the identity.
no, you said use I should say compound.
Identities, I can't tell you which one. Alright. So that's the way you do first principle, let's do a little paper pass, and then look at the application. Right?
That's it.
I'm sorry for that.
That's fine. That's fully done.
Alright, so just differentiate one phenomenon plus 2x. We're done with this. And I want to talk through some applications. And we're done. Right? Right? When you finish, try cos 2x, please. Cos 2x. First principle, cos 2x. Yeah. F of x is equal to cos 2x. That's the last one in this. Identity, yes. Try the same one. Well done. Cos 2x. Huh? Now, look back at your identity. I know it. No. It wouldn't be cos 2 open bracket x plus h, right? Try to expand it out and see. Right, so when you reach here and you multiply it out, you will end up with 2x plus 2h, right? And then you expand it out just like last time, right? And what you will get?
Cos 2x cos 2h.
So you have the limit as h approaches 0 of cos 2x cos 2h minus
Sin 2x sin
all over minus cos x all over h, right? Cos 2x. Can I bring the cos 2x part together again? Yeah, Nikolai? Can I bring the cos 2x part together? We follow the exact same pattern. So I'm bringing the cos 2x together. All over h minus the limit as h approaches 0 of sin 2x sin 2h all over h, right? Right? H over h. Well, watch this here. What to pull out here? Cos 2x. The limit as h approaches 0 of cos 2h minus 1 over h. Problem. What to do about this problem? Right? Multiply by 2 here, multiply by, well, I'm putting the 2 outside here, right? That's okay? So I multiply the numerator by 2 and denominator by 2. Okay, so I put the 2 here one time. Remember, it's right here, 2 by 2, 2 is here, 2 by this, pull the 2 outside, right? So what to do here now? Pull out sin 2x and multiply by multiply by 2 here, multiply by 2 here. What is this? What is it? This is 0. Right? So it's 0 minus, what is this here?
1.
So the answer is this whole thing here. That whole thing there is 0. This whole thing here is 1. So it's 0 minus 2. And that is your answer. All right. That is your answer. And that's it. Oh, just give it a wheels and thread. I mean, ladies benefit. Of course, it doesn't. Okay, then. Like me, it's a go for a lunch. Like a coffee. Those are spreads. And it is the same lady. You'll have one cafeteria. One. So, also the menu today.
Yeah, it's run by the same lady.
So the ladies bring it across, so let's put it by order. And let's cook it by one of the schools.
Yeah. That's not.
What is the food is quite cool, so I want to know where it coming from. We thought of here too.
I already.
So I feel it's pearls. What is? Yeah. I know we're talking about what. All right, nice. Okay. So that is the first part of differentiation. I just want to run through some things you remember from, hopefully remember from Form 5 and every stuff, right? And all of those. Okay? But hopefully at the end of today, you should be able to do limits properly. No? So can you limit? Do differentiation and basic differentiation and differentiation by first principles, right? Yeah, that's fine. So it'll be like a little part of it. All right, so let's take a look at some applications. We're not doing anything, so let's listen to me for a little bit, right? Right. So some of the applications of differentiation. Anyway, some of the applications of differentiation that hopefully you remember. Number one, you should remember that dy dx represents something called a gradient function. Right? So if you want the gradient, just plug in an x value into that function and you go to. Right? Remember that? Second thing you need to remember, the one that nobody likes, rates of change. So if I ask you to find the rate of change of y, that is the rate of change of y. What do we use again? What is used to find the rate of change of y? Chain rule, remember?
Yeah.
Chain rule.
Yeah.
dy here, dt here, and the next variable here.
Yeah.
Let's assume it's x. It could be r, it could be anything. All right? So you have to remember that you can use differentiation for rates of change questions. Then the one that's the most popular is maximum and max and min problems. So if you put dy dx equal to 0, what do you find again? Find the stationary points. Right? Yeah, coming up to that number. What is differentiation?
Oh, but that's no differential equation.
So we may reach a differential equation as a whole new thing. Okay? Differential equations is when you have to solve a differential by integrating. So we reach here there. Yeah. So dy dx equal to 0 gives you stationary points, and if d2y dx squared is more than 0, you have a minimum. If d2y dx squared is less than 0, you have a maximum. Right? All of this here is your Form 5 rule. But there is an in-between. Right? There's an in-between point called a point of inflection. Right? That's the new stuff. How do you just introduce it, but not be able to work with it? Just an idea that exists. Right? But now we need to learn about, so remember, minimum is this, maximum is this. But there's a point that looks like this. Increasing, and then the function, sorry, decrease, and then we get to increase. Right? That point there is a point of inflection. So next week, we're going to take a look at how to find that point. Right? So we're going to look at inflection. That's the main focus on this application. Huh? Yeah, that's where you do the number line, find the values, and determine if it's max or min, or if it's actually a point of inflection. Okay, so those are the things that you need to know about differentiation. Of course, I didn't mention it, but you have to know how to get second differential, right? Not by first principle, just normal. You have to be able to differentiate twice. Okay? So that is your differentiation. Next week we'll do the applications and start the integration. All right? I think so. What is it like? Yeah, I know. I see one myself. I don't want to